Hello and namaste guys. Today I will be discussing about 3 reservoir problems and type 1 problem. Let me read the question for you. 3 reservoirs A, B and C are connected by a pipe system having length 700 meter, 1200 meter and 500 meter and diameters 300 millimeter, 250 millimeter and 300 millimeter respectively. The water level in reservoir A and B from the datum line are 50 meter and 45 meter respectively. The level of water in reservoir C is below the level of water in reservoir B. Find the discharge into or from the reservoir B and C if the rate of flow from reservoir A is 150 liter per second, and find the height of water level in the reservoir C. Taking off. This is coefficient of friction for all pipe F is equal to 0.005. This question has been asked in Provincial University 2022 in 8 marks. So, what are given? Length of pipe between reservoir A, B and C and junction J is given, and their diameter are also given. To convert millimeter into meter, we divide by 1000. And Z1 and Z2 are elevation of surface of reservoir A and B. Z3 is less than Z2. That means level of water surface of reservoir C is less than that of B. And we have been given discharge of 150 LPS divided by 1000 gives 0.15 meter cube per second, and this is coefficient of friction because there is 2 0 after points, so that is coefficient of friction. So we have to calculate discharge in two pipes and reservoir of C. So this one is top reservoir and this is datum line, and from datum line to surface this height is called Z1, and this is second reservoir and Z2, and this is third reservoir with elevation Z3. This is reservoir A as given in question. This is reservoir B and this is reservoir C. Now next step is to connect pipe. 3 pipe, 1, 2 connects B and pipe 3 connects C to the junction J. This reservoir is top, so water flows from A to J, and Z3 is smallest, so water flows from junction to 3, and elevation of junction J from datum line is ZJ, but we don't know the direction of water in pipe 2, so I haven't drawn arrow. So this 0.005 is coefficient of friction. To convert it into friction factor, we multiply it by 4, and friction factor is 0.02. We know the formula of head loss as let me write formula. F1 means F means frictional head loss. F1 means frictional head loss at pipe 1, and this is given by Darcy-Weisbach formula as F L B square upon 2 G D. The value of F or F dash is this is frictional factor is 0.02, length 1 is given, and diameter of pi 1 d1 is also given, but we don't know the value of this velocity. But we know this charge is equal to area times velocity v. So v equals discharge q divided by area, and area is nothing but pi d square divided by 4. So velocity becomes 4q divided by pi d square. So take this value and substitute here. It also becomes f l b means b square means 4 square, that is 16, and q square divided by 2g d, and this pi d square. Square of pi d square means pi square into d4, and this 2 and 16 cancels and gives 8, and f l is remains, and this q square divided by pi square g and d power 5. So we derived this. Yes, f1 equals 8 f l q square upon pi square g d raised to power 5. So erase this. So f is given 0.002, l1 is given, t1 is also given in question, value of g is 9.81, and d1 is also given in question. So we can find the value of f1, that means head loss at pipe 1, and that comes 10.611 meter. And j means head of junction j, which is given by head of this head minus head loss in this pipe. So total head at this is datum head z1 plus velocity head v1 square upon 2g, and pressure head is p1 upon rho g or gamma. So here pressure is 0 because this is open to atmosphere, and gauge pressure of atmosphere pressure is 0, so this value becomes 0, and velocity is also 0 because area of reservoir is very large compared to this pipe. So the total head is this z1. So head at junction j is z1 minus hf1, and that gives 39.289. So since since z2 means this is greater than j, head of elevation head of j is this, and total head of j is maybe over here. So z2 is greater than this J. So water flows from B to J. So direction is this was, and from J to C because C is the lowest point. That means, so I have drawn arrow here. This is Q1 means discharge in pipe 1, Q2 means discharge in pipe 2. Similarly, Q3 means discharge in pipe 3. So at junction J, using continuity equation, Q1 plus Q, that means discharge in is equal to discharge out Q3. So Q3 equals Q1 plus Q2. And again, F2, head loss in pipe 2 is given by Z2 minus Z. Elevation of value of Z2 is given in the question, and J we have find already. So F2, head loss in pipe 2 is equal to 5.711 meter. We know F is equal to RQ square because we have already derived this formula. In this formula, for two pipe, all the thing is constant. It is constant, F is constant, length is constant, G is constant, pi is constant, diameter is constant. So this constant we denote it by R2, so only the variable is Q2. So we put the values and got discharge Q2, that is 0.053 meter cube per second. Q1 is given in question, Q2 is 0.053, so we can calculate Q3 as 0.203 meter cube per second. And again, using from this formula, all the values in right hand side is given, so value of left hand side or head loss at pipe 3 is calculated as 14.012 meter. And finally, we have calculated total head at junction J, and we know the head loss in pipe 3. So Z3 elevation, so elevation at 3 equals J, means head at junction J minus head loss in pipe 3. So 39.289 minus 14.012, this is 25.277 meter. So elevation of C is 25.277 meter. So thanks for watching. Hit that like button, subscribe the video, share it to your friends, and follow me on social media.